In this video, we're going to discuss one-way analysis of variance, or one-way ANOVA. So essentially what you're trying to do is figure out, are the means of three or more groups significantly different? You could actually do two groups, but most people do three or more groups. So suppose in a bookstore, we put displays of computer books certain weeks at the front of the store, the back of the store, the middle of the store, and we don't think there's any other significant factor except that the position in the store of where we put the computer books that affects sales. So this is how many hundreds of books we saw sold each week. Is there a significant difference in the means? Well, that's where analysis of variance comes in. So this is in the data analysis tool pack. So remember, file, options, we'll go add-ins, go, and then we can basically have analysis tool pack, the first option checked. And then if we go data tab, we go data analysis. Okay, ANOVA single factor. We'll do the others in later videos. Okay, so what do you have to put in here? Input range is your data, including the headings. Okay, so that would be B3 through D8 there. And then labels in the first row, because we have labels. Now output range, upper left-hand corner, could be anywhere, and so we'll go here. So let's see what we got. Okay, so we got the mean sales in the front was 900, back 1400, the middle 1100. The question is, are those means significantly different? And you might say, why is it called analysis of variance? Well, you'll see that a little bit later here. But it depends on the variant. Your conclusion depends on the variance within the groups. These are the groups. So we can see we're pretty consistent within the front, back, and middle on what we sell. That makes it easy to differentiate the means of the three groups. So what you do is look at the p-value like we talked about in multiple regression. So p-value, some people say less than 0.05. Let's say, well, we'll say less than or equal to 0.05. Means the groups are significantly different. Groups have significantly different means. Okay, so there's like 3 chances in 1,000 that these means are not significantly different. Now you have assumptions you need to check that basically within each group the measurements are normally distributed and the variance of the data in each group are not significantly different, but we just don't have time to cover that. Okay, so now we wanted to make a prediction. If we wanted to predict sales in a group, we need a standard deviation. So we can get 95% of the time we're within 2 standard deviations of the prediction. Okay. And so what that would be, it turns out, is the square root of this mean square error here, which is going to be about 1.56. Okay. So then we could basically say that's 156 books. So if we would look at basically the front of the store, and we'll suppose these are weekly sales, how many 95% sure between blank and blank books will be sold in a week. Well, we know the mean is 900, so we'd go 900 plus or minus 2 times that 156. So we'd go 900 or 9 minus 2 times 1.56. And we go 9 plus 2 times 1.56. So between 588 and 1,212 books. %95 chance. Okay, so what happens if the means are not significantly different? And so here we have actually, I made up a data set. The means will be exactly the same in each group, but we'll accept the hypothesis that the means are the same. Okay, so here we reject the hypothesis the means are identical. with a low p-value. And the reason we can do that, it turns out, is because there's a lot of consistency between the groups, within the groups. Okay, there's not much variability within the groups. But in our next example, there'll be a lot of variability within the groups. So the means here are exactly the same. Let's check that. So the means are going to be 900, 1400, 1100. So let's do the ANOVA here. It seems like we should conclude the means are significantly different because the means are the same. But there's a lot more variability within the groups, so we can't conclude that, as you'll see. Okay, so now it's B3 through D8. It remembers that. It's a different worksheet, though. And we can put the output here. Okay, now look here. P-value 0.66. Accept the hypothesis mean sales are identical for each position in the bookstore. Okay, and the reason we can't conclude these means are different, even though they're the same means as we had in our previous example, is there's a lot more variability, okay, basically within each group. I mean, the sum of squares there is 574 within the group. Don't worry too much about how that comes about. The sum of squares within the group here was only 22. That's a measure of the variability within the group. So in this case, you can see why it's called analysis of variance. So we could go into great detail on how you get these sum of squares and stuff like that. But the key is the p-value. Low p-value, you conclude the means are significantly different. High p-value, you conclude they're identical. Now, you might want to say, for instance, what's the chance that basically the back is the best because the mean was the highest? That would require something like resampling, which we may talk about in future videos.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.